So let me explain server and client communication using packet tracing, and you will get more idea about three-way handshake and how to access different services from the server, and how to assign IP addresses, and how to look at the MAC addresses. All right. So in packet tracer, you first, let's have an end device, and I'm gonna have a end device, and this PC, it doesn't has any it doesn't have any IP address at this point, but we have on a PC, and we will assign an IP address to it. And I'm gonna put one server. Okay. And let's look at the PC first, right? If I double click on it, and if I go to configuration, and then I go to the internet interface, fast ethernet 0 interface, and then you will see that it has a MAC address, this one. So you can change this MAC address. It is an hexadecimal address, but you can change it. But let's go with the default setting, right? And I'm gonna assign an IP address, let's say 10.1.1.1, and the default subnet mask is 255.0.0.0. And what is subnet mask? That we will look in IP addressing chapter. That is actually chapter 3, that discuss about IP addressing and why we have 255. So that chapter is and this is a binary, and the chapter 4. Let me give you a brief introduction about why we have 255 over this. Because we have the network part, because that IP address that we have just assigned to this PC is 10.1.1, right? That is 10.1.1. That means it's a class A IP address. And we have, and if we look at our slide, so that's mean the network part is 8 bits, and 24 bits actually assigned to the host. So that's why we have the default subnet mask is a 255.0.0.0. That's mean if we have 4 octet and 4 octet of if we convert that binary of the first octet one, and we turn all the bits 111 for the first octet, then that will be equal to 255. All right. So I think this is an example. You can get an idea of what is why we have to 55, because if we turn on these all bits to 1, that will be equal to 255, and then we have 0, the second octet, third octet, and the fourth octet. All right. So in the point here is that the default subnet mask is 255.0.0, and I have assigned the class A IP address. All right. And then I am gonna assign IP address to the server, and I'm going to configuration setting, and go to in fast Ethernet interface, and again now I'm gonna assign 10.1.1.2 it, and it will have a default subnet mask of 255.0.0, because that's the class A IP address. All right. And it has it's a MAC address, this one. So what kind of services we have for this server? So we have HTTP on, and we also have HTTPS on, right? And we have other services like DHCP, excuse me, and we have also an FTP, and we have domain resolution, and then we have uh, TFTP. So different services is provided to you by the server, right? So it's in a simulation environment, right? And and we have assigned an IP addresses, like we assign IP address to this interface, that 10.1.2. All right. So now let's make a connection between them, and let's have a look at communication between a client and a server, right? So I'm gonna make a connection from this fast Ethernet 0 interface to the server, to the fast Ethernet 0 interface. All right. Now now let's have a three-way handshake first, and let's see and how they communicate with each other using a simulation mode. So I'm gonna turn into simulation mode, and I'm gonna open the PC interface, and I open the PC interface, and Go to the web browser. All right, so I'm gonna access HTTP first, right? So HTTP, and but we know that we also have an HTTPS service as well. So I'm gonna type HTTP and colons dot 10 dot 1 dot 2, sorry, 1.2. So that's an IP address of the of our server. And if I press go, and you will see in a packets will now move from client to the server. And in a simulation mode, I'm going to press now the next button. So I like to move this packet to go to the server, and then we have some communication and servers going on here. All right, so let's make it minimize a little bit and press this next button so that server and the packets can move to the server. And if I look at this packet, let me maximize a little bit from here on the right side, and you will get a more idea, right? So it's saying that it's an ARP request, okay? And then the next packet is that now there is a TCP packet is coming back to the client. And then if I again press next, it will again a TCP packet, and now there's an HTTP packet because we now trying to access the website that is HTTP 1.10.1.1.2. All right, and now again it is a TCP, but on the top from HTTP, and on the top there is an TCP, and I'm sure that now we will have a website running there. If I go to website, so it's so the last packet, so this is going to be our last packet so that we can access the website. No, it's I think one more packet we need. All right, so that's an idea of how we can access, how to simulate this environment in a packet tracer. So I have one uh, a client, and then I have a server there, right? And I did a very little communication between client and server, right? So there is also a lot of other information that we have. That mean if you mm, click on these different and these different rows, and you will see a lot of other information that you will learn in an OSI model. All right, so if let's say I open this, the last packet, and you will see that it has information that outbound PDU. That's I mean this is the information is coming from from the from from the server, right? So we have port. This is the first layer, physical layer, then the data link layer, and then the transport, and then on the top we have TCP, right? And that TCP, the source port is 1025, and the destination port was 80 because HTTP is on. We were trying to communicate on port 80. All right, and if I look at another packet, and you will see that this this is very interesting, that you can see that on layer 7 that we have an HTTP as well, because on OSI model we have 7 layers, and 7 layers is all about these 7 layer is all about sending packet from physical device, from physical layer to the application layer, right? So if we have physical data, network, transport, session, and presentation and application on the top. So that's mean this information, if we look at this, we have 7 layers. Even fifth and sixth is missing, but then on the top we have an HTTP, so that we have physical, then we data, and then we have the network, and then we have the transport, and then we have the session, presentation, and application on the top, right? So that's the simulation environment that we have in packet tracer. Now let's have a look at the OSI model. So I think that's I presented in the last class, and now let's look at the OSI model. So in OSI model, that stands for that stands for uh, let wait a minute. So that's an open system interconnection model, is a framework that describe how computers communicate with each other over the network, right? It's like setting some rules and layers, because otherwise there will be some security issues that we discussed in the previous class, that what kind of security issues we could have. So each layer will play its own role. Okay, so what kind of security issues we're gonna have? So we're gonna have issues like let me switch back to my security slides. So what can we can have, maybe have DDoS attack, or maybe we have sniffing and IP spoofing. So these kind of securities, to overcome these issues. So these these layering, these layers actually provide some rules and regulation. Each layer had its own functionality, and it's to remember these all layers. I have some analogy. That analogy is about saying that all people sleeping through networking don't pass. Okay, so now I will make this connection with all and people and sleeping through networking don't pass with the layers of the OSI model. That is, that the all is gonna be an application layer. This is the seventh layer that we have. And then the people presentation layer, then the sleeping will be the session, through it will be a transport, networking will be the network, and then data, and then physical, the first layer that we have. All right, so let's make it more easy to understand that how these all layers will actually work. So in OSI model, so the analogy, let's make an analogy in a real world scenario. So though imagine you are sending a package from your house, to your friend's house, and this is how these 7 layers work. Okay, so the layer one with the physical layer, that this is the actual road your package will travel on, and it represents the physical wires like cables or wireless signals, right? And then the data link will be the truck. That truck is responsible for moving your package along the road, and it also ensures the package gets correct street and neighborhood. All right, and then we have layer 3, that will be a map and GPS. So that's mean the map or the GPS decide the best route to your friend house. Okay, it handle racing, routing to ensure package knows where to go. And the layer 4 is the transport, that you maybe you need to split your package into multiple segments, and then at the end you need to put in different envelopes. And then, so in layer 4 actually we also made them segments. In networking point of view, these are segments, but let's say in this analogy, these will be where we are going to put some shipping labels. And layer 5 is like a doorbell. This layer starts at the end of conversation between you and your friend, like ringing the door will let them know the package is arriving. All right, and then we have the sixth layer, that is presentation, that unwrapping the package. Once your friend get the package, they unwrap it and see the contents inside it. And the final one, the gift, the inside, it's like the gift inside the package where your friend actually uses like application browser on your computers. So that's the analogy of these 7 layers in a real world scenario. But let's try to look at in networking point of view. All right, so in an OSI model we have these 7 layers, but in TCP/IP stack we convert these layers from fifth to 7. We name them as an application, and then we have the fourth. So they think that these are the most important in TCP and IP. So all right, so what are the functionality of these 7 layers? So on the top we have an HTTP that we have just seen, using a using a packet tracer. We could use an HTTPS, and there could be an FTP. And transport could be TCP and UDP. TCP is more reliable, and UDP is that if packet got corrupted, you cannot, it's not reliable in this way. Right, you cannot send the packet again. You can send the packet, but not the same packet sending again. And then network will be routers, and then data will be switches and hub. All right, so on layer 2 we have switches and net. On layer 3 we have routers, and on transport we have uh, a protocol that will be a TCP or the UDP. All right, so now let's look again some networking point of these 7 layers. So on physical layers we have some bits and in the form of 01 format, and then on data link we have data layer, we have frames. So there's those bits will be, we call them frames. And on layer 3 we have packets. And on transport we have segments. And on fifth to 7 is actually an application, what we are using in an application, right? All right, so now let's look at each layer one by one, and we conclude about this OSI model in this lecture. That so the physical layer is all about your hardware that enables data transfer, and it deals with zero ones. Okay, that we have just seen that these on layer, on the first layer, that will be on bits, that will be in the form of zero one. Bits mean zero one, right, in a binary. And then key examples is that you're using your maybe Wi-Fi signals and your hubs, right, and Ethernet cables are on the physical layer. And then the data links, we the data will be in the form of frames, and think of frames like neatly packed envelopes containing your data. All right, and this layer also ensure the data is sent to the right device, and if it also checks if the data is in frame was corrupted during transmission, and if there is an error, then the frame may be retransmitted. Okay, this layer is also responsible for retransmission. It ensures one device doesn't overwhelm another with too much data too quickly, right? So there also comes the concept of queuing here as well. All right. So now in third layer, we have logical addresses that are IP addresses, that each device will have an IP address, and it can be uniquely identified on a network. And we also determines the best path to the destinations on this layer. So when you send a message to someone on the internet, this layer ensures your data packet knows how to navigate through the different network to reach them. All right, this layer is responsible for that kind of functionality provides to us. All right. So in transport layer, so we discussed that on the top of a network layer, we have transport layer that provides a more reliability protocols like TCP, transmission control protocol, that is reliable, ensure data is received, and if there is any error, then TCP is responsible for sending the data again. And then UDP, we have UDP, that's mean user datagram protocol, that acts most of time we use in video streaming and gaming. If packet is encrypted, that doesn't mean that you need to you will get retransmission. That's mean you have to say it again. It's exactly same something like on a video streaming session, a Zoom. If something is wrong during the network in during the communication, then you have to say it again. The other guy will say, "Pardon, can you repeat again?" Then you will say again, so there is no retransmission here, right? And it also identifies port. So for HTTP we have port 80, and HTTPS the port is 443. So let's have a look of this port 443 for HTTPS, right? So in the previous previously we look at HTTP. Let's close this communication, and let's try to have a HTTPS communication here. So let's again click on real-time communication and simulation, and open the packet terminal of the PC, and then open web browser. Actually, I like to show an HTTPS is on port 443. And now instead of typing in HTTP, I will type HTTPS, and then colon slash slash 10.1.1.2. All right, and now let's send few packets to the server, and let's also have a look at here on the right side. So that's mean we're gonna have a HTTPS protocol here right now. So you see now we have an HTTPS. Just click on this one, and you will observe that the port will be 443 here. Okay, the output layer is so the TCP will be on 1026 port, but the destination port, the server port is 443. All right. All right. So now we have looked at the four layer, and the session layer is just maintaining a session between communication between application, ensure session remain open and synchronized. All right. And the sixth layer is about presentation layer, that prepares the data of application layer by translating into a readable format then, right? So it also handle encryption, compression, and data encoding. So that's mean if it if you're downloading an mp3 file, and that comes through from all these layer, from physical to the presentation layer, that you need an mp3 file, right? So that's mean you convert data to format like jpeg, mp3, or html, right? So this is the this is the functionality of this presentation layer. All right, so and the final layer is your application, where we use in http, https, different kind of application, we open it. And this, so we now look at these all layers and their functionality, and let's just summarize these all layers. So that we have a physical layer that transmit raw bit via hardware, and then the data link handles local network data transfer, error checking, network routes the data across different network using IP addresses, that we have assigned IP addresses using a Wireshark that you have just seen, pardon, using packet tracer, and you have seen that. And then transport ensures data delivery and proper sequencing. Session manage ongoing communication and presentation, translates encryption and format the data, and application provides services to the end user. So that's the summary of an OSI